Hey everyone, and welcome to this explainer. Today, we are unpacking a seriously clever, cutting-edge technique for AI text summarization straight from the resources at Learn Prompting. It's called chain of density, or CoD for short. Honestly, if you've ever asked a language model to summarize a document and felt totally underwhelmed by what you got back, you are definitely going to want to pay close attention to this. Let's start with a shared frustration that I know so many of us, developers, prompt engineers, and just everyday users, face all the time. Why are AI-generated summaries usually either way too long or completely missing the most crucial facts? It's a classic problem, right? Vanilla large language models struggle immensely to balance brevity and informativeness in a single pass. You ask for a quick summary, and it gives you this vague, useless overview. But then, you ask for details, and suddenly it's writing you an entire novel, and probably hallucinating a few bizarre plot twists along the way. Fixing that exact tension is exactly what we're focusing on today. So here is our roadmap for today. We're going to start with the AI summarization problem, introduce chain of density, cover the mechanics of CoD, build the CoD prompt, compare summary methods, and finally look at limitations and future potential. Let's dive right into Section 1, the AI summarization problem. The fundamental issue we're dealing with here is that text summarization requires a really delicate, almost impossible balance between brevity and informativeness. Modern large language models have absolutely revolutionized natural language processing because, they're incredible at generating coherent, readable text right out of the box without needing heavy fine-tuning. But creating a summary that is simultaneously concise and densely packed with rich information, that is notoriously difficult. Usually, as an AI compresses the text, it just strips away all the hard facts, leaving behind a really smooth but totally hollow narrative. Which brings us to Section 2, introducing chain of density. Here is the absolute breakthrough. Chain of density, or CoD, is an innovative prompting approach that systematically enriches summaries with missing entities, while strictly maintaining a fixed length. I really want you to let that sink in for a second. The summary gets richer, the facts get denser, but the word count never gets longer. It literally forces the AI to swap out the useless fluff for hard data. This technique is built on 3 core pillars. First up is iterative refinement. Instead of the AI just taking one single pass and calling it a day, CoD forces the model to refine the text over multiple iterations, grabbing missing details and meticulously layering them in. Second is controlled compression, which is where the real magic happens. Because the prompt strictly limits the token count, the model has to compress redundant language to literally make space for the new facts. And third, enhanced abstraction. As the summary is repeatedly reworked and squeezed, the language naturally shifts away from just copy-pasting the source text, moving toward a highly abstract, synthesized narrative that captures the true essence of the material. All right, let's move to Section 3, the mechanics of CoD. So, how does this actually work? This procedural arc transforms basic summarization into a highly sophisticated loop. Step 1. The AI generates an initial entity-sparse summary. It deliberately only includes 1 to 3 salient entities. This establishes our fixed length. Step 2. The model scans the source text to identify missing, highly important entities. And Step 3. The model must fuse those missing entities into a brand new summary that is the exact same length as the first one. The AI actually repeats this specific loop 5 times. With every single pass, it incrementally layers in crucial details by squeezing out the unnecessary words. Now, the prompt enforces very strict criteria for these missing entities. The model can't just throw random big words in to sound smart. The added entities must be relevant to the primary narrative. They must be specific, which is strictly defined as 5 words or fewer so they don't bloat the text. They have to be novel, meaning they haven't been used in any previous summary iteration. They absolutely must be faithful, meaning they actually exist in the original article. And finally, they can be drawn from anywhere in the source text. These strict guardrails ensure that every single edition truly elevates the quality of the summary. You know how Goldilocks wanted her porridge just right? Well, for AI summaries, the number 0.15 is our Goldilocks zone. Human evaluations have shown that the ultimate goal is achieving a density of around 0.15 entities per token. If the density is too low, the summary is just useless fluff. If it's too high, it reads like a robotic, rapid-fire list of facts that is honestly painful for a human to parse. A ratio of 0.15 aligns perfectly with human reading preferences, offering the absolute ideal blend of deep information and natural readability. Let's look at Section 4, building the CoD prompt. This is where the prompt engineering gets incredibly clever. The template literally tricks the LLM into giving itself room to work. You explicitly instruct the AI that the very first summary should be about 80 words long, but highly nonspecific. You actually tell the AI to use verbose language and fluffy fill-in phrases like the article discusses. Why on earth would you do that? Because you are intentionally creating a bank of useless words. Then, in steps 2 through 5, the instructions tell the AI to make every word count by deleting those uninformative phrases to make space for the dense facts. You're basically giving the AI a budget of words and then forcing it to spend that budget more wisely with every single iteration. And this brilliantly illustrates the real-world impact. In the source material, they test this exact prompt on an article about a Formula One Chinese Grand Prix incident. In step 1, the summary is a completely broad overview. It just mentions a collision and some vague consequences. But by step 4, it is a tightly packed powerhouse of information. It seamlessly integrates specific penalties, exact driver movements, lap numbers, and damage specifics, all without adding a single extra word to the overall count. It just completely proves how this evolutionary process transforms basic text into a highly informative asset. Human testing actually shows that steps 3 and 4 usually hit that perfect optimal balance before it becomes too dense. Moving on to Section 5, Comparing Summary Methods. This comparative analysis makes the current landscape very clear. Vanilla summarization is fast and straightforward because it's just a single step, but its fatal flaw is that it almost always misses the crucial details. Human-written summaries, of course, are context-rich and highly readable, but let's be real, they are subjective and incredibly time-intensive to produce. Then we have CoD. Its massive strength is the incremental integration of detail, creating a dense, highly informative text automatically. However, as noted in the limitations column, its primary drawback is the requirement for multiple processing steps under the hood. Which leads us nicely into Section 6, Limitations and Future Potential. Look, while this methodology is incredibly advanced, it's really vital to understand its practical limitations. Currently, chain of density is primarily tested and focused on new summarization, so its domain specificity is somewhat narrow right now. There are also evaluation challenges, simply because what counts as optimal density can be somewhat subjective depending on who is reading it. But the biggest hurdle for sure is computational overhead. Because CoD requires the AI to loop through 5 specific generation and revision steps, it takes more time and compute power, which can heavily impact real-time performance and efficiency for developers. Furthermore, the final quality is always going to vary depending on the underlying source material and the specific model you choose to use. But despite those hurdles, the potential is vast. For the developers and prompt engineers tuning in who want to practically apply or fine-tune this technique on their own, the creators of this method have provided an absolute goldmine of a resource. You can explore a dedicated dataset on Hugging Face that features 500 annotated and 5,000 unannotated examples of chain of density in action. It is quite literally the perfect starting point to start experimenting with this structured methodology today. Which leaves us with this final thought. We are rapidly moving away from treating AI as a simple vending machine, where you put a prompt in and get a single answer out, and moving towards treating it as a reasoning engine that iterates, critiques, and refines its own work. So how will iterative reasoning techniques like chain of density change our relationship with LLMs in the future? It's a fascinating question, and one I really hope you all explore as you test out these structured prompting techniques for yourselves. Thank you so much for joining me on this explainer, and keep learning.